Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night. I'm going to get chat up. All right. So, we've been decompiling various weapon functions in Castlevania Symphony of the Night, and that's what we're going to continue to do today. The number of weapon functions remaining is 23, so we're getting really close. Again, I think it's going to be about 2 weeks or so, maybe a little longer, before the rest of the weapon functions are decompiled, and hopefully we can contribute more to that today. The Castlevania Symphony of the Night decompilation project is attempting to recreate source code that is compatible with the original release of Castlevania Symphony of the Night for the PlayStation, but also versions for the PSP, the Xbox 360, which is largely based on the original PS1 version, and then potentially the later ports, which are based on the PSP version. If you want to know more about the project, you can go to SOTN.z.dev, where we have multiple graphs looking at progress for different objects that were shipped with the original game. The top ones are for the PlayStation, and then we have some ones for the JP build down below. We're going to be focusing on weapons today, where we have about 23% of the functions remaining, and hopefully we can make a little progress. The code is stored in GitHub. This is linked from SOTN.z.dev, and you can see the progress being made, or if you want to get involved and contribute back, this is a good place to start. There's wikis about how to extract data from your game disks, how to use decomp.me and other tools to decompile. And then there's also links to the Discord at the top, where people can help with decompiling. We chat there about different issues that we found along the way, and just a general interest in the game, how it can be changed, what will happen when we have full decompilations of various modules and things like that. Biz Murphy, who's been on the stream in chat a lot lately, has a nice spreadsheet of the remaining weapon functions. Looking at this, I often go to the terminal to find the smallest one, but I believe, if I'm reading his spreadsheet correctly, 49 is going to be the one that we look at today. And just because it's a smaller function doesn't mean that it's going to be easy. And just because it's a bigger function doesn't mean it's going to be hard. But I try to find things that will be able to be completed in about an hour and a half on the stream. So let's go to the terminal, and I have this fun. My dream, I have small dreams, but my dream is to have either Richter or Alucard animating as we compile. I think that would be fun. This is a little animation I put together that I thought was amusing, and amused me at least. So we have a project that's compiling, and I'm just going to double check that that actually is the smallest. Yeah, so I want to look for assembly files. So there's a lot of different ways to find these functions. I tend to use just the standard POSIX tools. Yeah, 49 is correct. That's the smallest one, so that must be line numbers. Let's open that up and see. looks like. So yeah, 194 is the line number. So that should be relatively quick. And so maybe we'll set a timer on this one as well. Just looking through it. I may have looked at this one earlier. The complications in this one are the this mflow and multiply. The M2C, which does an initial pass at decompilation, in general, I haven't found as good at these idioms. And I haven't necessarily found a good example of those either. We can look at it. Let me see if I've attempted this one. Let's see if I've So we'll go to decomp.me and look for any scratches that have been done. This was 49. I have not attempted this. It looks like Josh has... Oh, and Josh has a match. So we will not be doing that one today because it has been matched. Okay, let's go back. Find the next one. We can look at 51. There is another one in 49. Two more in 49. They're all about the same size, so I'm going to look for those and see if those have been worked on. Oh, actually, are these... No, those were just made today. So, we have matches on 10, a close match on C. It doesn't look like much more is necessary to do there, but that's Josh's work. I'll let him keep that. A little more to do. Oh, that one's the same. 49. This one is also mostly done, so we'll stay away from weapon 49. Okay, so the next best place to look might be weapon 50 or weapon 15. We'll look at that 15. So I don't see any previous work here. Let's look at that one. We were looking at 10. This one is potentially more straightforward. So yeah, let's set a timer on this one. We'll see if we can do it fast. I'll still narrate along the way, but the goal here is to get to something quickly. So the rules of that I've given myself for these timed decompilations are pretty simple. The timer will start when I create the scratch. Oops. I have access to any tools or previous code that I want, and I don't need to get a perfect PR ready code. I just need to get something that matches and then compiles with all OKs in the project. So when I run make, I should get all OKs. All right, I think that's it. I'm going to set my timer up. And 3, 2, 1, let's go. So decomp.me is a tool for decompiling. It will do a first pass at this function and try to decompile it. But it doesn't always know what how the structure of the code is, and so it's not expected that this will get a perfect match. But it's a good starting point. So we have some entity that we don't know what it is yet, so that will add some complication, but everything else is pretty small. We know most of the types except for one here, and it's going to be either assigned or unsigned 16-bit based on this offset. And so we will figure out what that is as we go along. So I'm going to do what I normally do, which is get things cleaned up. Why did my... And speed through as much of this as possible. We don't have a lot here, which is good. These player underscore, that's going to be struct access for the player object, which is the first object in an entities table. We don't know what this is. And it's also not referenced, so I'm not sure why it was inferred. I'm going to get rid of it for now, and we'll see if what we need to do. This is going to be struct access as well, and we'll be able to get rid of this. And so we should have a compiling project pretty soon. Argument 1 of set sprite bank 2, that's because we're passing a reference when we don't need to. And we're going to set this to return a 32-bit even though it doesn't need to. And the last one is line 33. We have a warning. This is not a reference. Okay, one more. So we do have another object called entity slot 16, and it looks like we can just use that. So I'm gonna make sure that this is size 34. I'm gonna get rid of this for now, and we'll see if that works. So we're at 84%. That's pretty good to start out with. There's going to be some common things that we need to do, but we can go through and get rid of variables. Is there any GAPI? There's not, and there's no goto, so this is actually a pretty good one. So this temp s0 underscore 2, we're going to call angle. Var a2. It's unclear what this is. It definitely is not an entity pointer. So that means we need something at offset 9C within the weapon extension, and that would be acceleration X, which makes sense. And so that we can call var a2 acceleration X. Var v0 is velocity y, and this is going to be similar. Actually, this is also going to be acceleration y. And we can rename that variable. Not necessarily, or not necessary for the getting to matching code, but useful for understanding things later. So rotation and temp s0 is params. That actually, we'll change that to a signed 32. And see if we can get rid of that. It's actually a signed 16. And that gets us a little closer. Unsigned 16. All right, so we, but that does not help us, so we'll call it that for now. All right, so going from top to bottom, we have on line 32, line 32 is our first mismatch. These are out of order. On line 45, we may have some out of order as well. The registers are wrong, and let's see. I'm going to pull this down. I'm going to pull this one down. Keep this close. And that works out. So I was looking at the registers that were being used, but also looking at the way the code was structured, and it looked like these two sections were about identical. And so when that happens, often formatting them the same works out. So then on line 59, typically X is set before Y. That does not help in this case. We may have to work on this ordering. I'll try reordering this. And that doesn't help. So we'll come back to that. At this point, I'm just trying to go quickly and not necessarily worried too much about specific registers and other things like that, just getting the code in place. So we're up to 93%, which is good. Temp S0, that was going to be params, and I didn't do that replacement. Oh, because I have temp V0. We should be able to get rid of some of these casts. So let's look down here on line 79. So we're doing a plus equals for velocity x. And this is going to be that same weapon acceleration x. And same here. Okay, and that's getting us much closer. And so what's remaining? So it looks like there's something out of order up here near line 60. 58. I'm going to try reordering these again. See if that falls into place. It does not. So let's look at what's happening. This can be changed into a minus equals, as well as this. And does that knock it into place? Not quite. So are these out of order? Oh, we're really close. So we're at 97%. Now let's go through and see what we're missing here. So up here on line 59, we're doing a mod by 40. And these are tricky. And I can never infer what the compiler is producing for these, which is unfortunate because that is going to be likely what sticks us for trying to get this quickly. I'm going to look for other places where the position X is being decremented by 14, and I found one that is promising, but it's not right. So let's look for places. I'm going to go to the terminal and look for places where we're modding rand by something. And yeah, we're using the rand without any argument. Okay, so we have cases of 10 and 4, 41, 12. What is a better way to do this than brute force? I don't really want to go through and do that. So we started with 40. What can we reason about? I know that I did solve this. Oh, here we go. And potentially these are in the wrong order. Or I need to reason about nothing. Or look at that. That's it. Okay. So now let's get this in. So I was looking at the assembly, and I noticed that values in the assembly were coming later when they should have been coming earlier. And so that gave me the hint that the values were right. They were just in the wrong order. Let's get to weapon 15, and we're looking at SOTN. Paste that in there. Get rid of this. Make. We don't know what an unknown force C is. Sorry. That's the animation frame. That wasn't matched. All right. Timer, stop. 13 minutes. Not a world record time, but pretty quick. The complexity there, and we'll go through another one of similar size and kind of talk through it a bit more, but the complexity there I often run into is with the modulus operators and the values those produce. We can look at the assembly And we see a lot of strange values. The compiler has lookup tables for how best to do modulus operations. And so in some cases, and this is one of them, doing multiplies by odd constants is faster, or so the compiler writer thought, faster than other methods of performing that same operation. Other times, there'll be several branches that fall down from the modulus operator when you're doing a modulus on a variable. I suppose this is variable as well. We don't know what the value of rand is going to be. And I don't have those tables memorized, so when I see the values, they look rather opaque to me. But we were able to get a match, and we did it in 13 minutes. That's okay. Let's look at the next one then, and we'll see if we can do anything with that one. So there's another of similar size in weapon 15, and since we've seen the structure of this one, it may be similar. I haven't looked at what weapon 15 is. I'm going to rename this so I can get back to it later. Excuse me. And then we can start on the next one. So let's go and look at weapon 15. So this is Shuriken, Buffalo Star. Okay. Somewhat curious that this hasn't been looked at yet, but we'll do this one next, and we'll time this one too. If people want me to slow down, I'm trying to go fast, but if people want me to slow down, feel free to chat, and I will. I want to have fun, but I want to also educate people along the way. So going fast is really just a challenge for me to see how quickly we can get some of these things done. So I'm going to look at entity weapon attack next. So I'm copying that assembly. And we'll start a new one, and we'll restart the timer as well. So I'll start a new scratch. And get things arranged so that I can see both things at the same time. And we'll go. I need some kind of OBS integration so that it starts my timer when I hit scratch, but I don't have that. So creating the scratch. And maybe a little more complicated, not much. We're going to kind of go through and do the same thing, clean up the project first. We want no built-in. And then go from there. Again, this is being multiplied by 2, which indicates that it is a signed or unsigned 16-bit array. And the cast here gives us the hint that it's signed. This unknown 31 we just saw, which is going to be the animation structure has no. What did I screw up there? We'll figure that out. I'm going to pull that up off screen again. Offset 31 is. Oh, its params shifted by 8. So we're gonna pull that out. This is being used several places, however. So if it's used several places, that tells me that it isn't pulled out into a variable and it's being accessed directly. This may be a union that we haven't made yet. So every time I see self unknown 31, I'm going to replace it with this. And oh shoot, not anim, params. There we go. And then, so we're compiling, we're already at 89%. That's great. So clean up the last warning, and let's go. We can do some of the same changes. So when we see things that look like they're in a particular order, it's likely that that they are. Oh, there are a few things here on GAPI that need to be fixed. So GAPI is accessed through a struct, but we have symbols that are mapped. And then all of these player underscores are also going to be struct access. When the assembly is extracted, they're given global symbols. And we can get rid of all these. This will clean things up as well. So line 36, 43, let's just do a getting much closer yet. So now let's replace this go to. If this condition doesn't hold, we're going to play this sound effect and then fall through. So let's think about that structure. That helped quite a bit. This G player is going to be accessed as a struct and an array. Okay, we're at 94. I'm not worried about the intermediate values. So on line 49, there's a move. And we see this occasionally. I'm going to attempt to force the move by changing the signature of this function. I don't know if that is the issue here, and it does not look like it is. So what else are we missing here? So we're storing this. Getting this offset of 2 from S0, and S0 is the object that was passed in, is out of order. Let's pull this up and see if that aligns that in. It does. Good. Okay, we have a bunch of immediates. Again, not too worried about those. Here, this hitbox offset is being loaded as signed value when it should be an unsigned on line 36. And the same thing here. Okay, we're getting closer. These immediates I'm not worried about. Immediates. All right, so line 83. This is a common idiom. Okay, we're incrementing the timer. And then checking hit flags. But we're missing a load. And that was it. And then line 92. Decrementing the timer. And comparing the timer with 0. And most of this other stuff can go away. But not today. Oh, I got rid of my decrement. And that should finish that off. All right, so 145. When the differences are an odd number, that means that it's not an address offset immediate value that's different. It's likely a different value. And on line 27, yeah, I forgot to get rid of that scale. So this is it. This works. We can get rid of this and go back, and we have entity weapon attack done. Stop the timer. 8:38. That's it. A new world record. The previous world record was 9 minutes and 23 seconds. Set last Thursday. And we destroyed it by an entire 50 seconds. Chat. You just witnessed history. History on this channel. Limited to weapon decompilation in Castlevania Symphony of the Night. I don't know if I can top that. So I'm not going to try. I'm just going to revel. I'm going to, let's see what kind of reactions I can do. We definitely need the party reaction. And maybe balloons. So, oh, and I didn't have the terminal there to prove. Really, I have not typed anything in here. This is this was really the way that it was. I was going fast. I can't be forced to switch windows. But that's great. So that's 2. So we were at 23 weapon functions remaining, and with a little bit of effort, we should be at 21 later this afternoon. So we will update the countdown. And I will save this. And maybe we'll look at the last. We have one more function in weapon 15 before it's done. And so we can look at that one and finish this off. It is longer, but hopefully not any more complicated than these were. So we're going to be looking at the function pointer C. I'm going to pull that assembly, and this one will go slow and methodically. Make sure I have this saved. Come back to it. Okay, so even on a longer function, we're going to have a lot of the same things. The main difference here from the other two that were being done is there's a lot more control logic. Entities in Symphony of the Night are mostly implemented as state machines, so it's very common to have switches with a bunch of different cases depending on what the state of the object or weapon is. We can take a look at as well one of the examples here, like Buffalo Star, which I know is used a lot for motion as well as just its abilities. Let's get our Symphony of the Night. Oh, and it's interesting that the wiki pulls these all out as similar things. I don't know. I haven't spent a lot of time in this wiki except getting background on something, so I'm not sure what the background of the people who are maintaining this is, but it's interesting that they've pulled all these out as the same weapon implementation. So there's our Buffalo Star. So we're going to go through and do the same things. We're going to... Eldritch mentioned that the wiki may be unreliable for things, which is fair. So this is a similar construct to what we saw before. We have a reference to some global variable, and then we're adding some offset multiplied by 2. The 2 indicates that it's 16-bit. Yesterday we found one that was multiplied by 14, and it turned out to be a structure that hadn't been seen before. But these are just short integers. And let's see what it's being cast as. Nothing's being cast there, so I'm going to assume it's signed. But we can change that if it needs to be. And likewise, this is being scaled by 2 as well. We'll see if this causes any issues. Sometimes these multiply high fall out. It may indicate that it's a modulus. It may indicate that it's a division, a different division of some sort. Oops. All right, so they're contributors. Whether I should open an issue with decomp.me to add no built-in as the default, and everybody else, it seems like they just get rid of this signatures in the context. I've mentioned it before. That's not my preferred solution because oh, that's interesting. I've not seen this macro. The signatures for the PS1 SDK memcopy are slightly different from the signatures for the built-in version, and so there's a possibility that different code would be generated. In general, though, there is a return value. That return value is going to accept is going to ultimately be 32 bits, regardless of whether the function says it's returning 32 bits or not. So I guess it really only depends if you're using that value. So this is returning a void star. I believe the GCC version returns a char star. Char. I say char. Okay, we'll go through and fix the player references. This reference to stack pointer 10. Collider often shows up that way. So we're creating a collider object which is bigger than the normal 32-bit variable that would be on the stack, and then passing pointers to it around. I'm not sure why M2C generates it this way. But that's not surprising. So we can replace that with Collider. And these conditions are going to be looking at the first value in the Collider, and I'll have to look that up and see what that is. GAPI we can fix. Um, 109. So that's telling us that, oh, here. This is, yeah, so this is, we need to pass in the field, or look at the field in Collider, not just the variable itself. And so when there's no unknown 6, unknown C, things like that, it's going to be the first field in that struct. And we can replace all those instances. So line 68, we have a problem. So here we'll replace these with array access. And this time remember to get rid of the multiply by 2. And there are way too many parentheses here. And then the same thing down here. And we'll have to see, those probably are separate statements. Okay, 156. The same thing, and we get rid of the scale. And I got rid of one too many parens. All right, so we have something that's compiling. And mostly okay. 83% is a good starting point. When we have go-tos, especially go-tos like this, these are all the same. It's just one call to destroy entity. The compiler optimized that out for some reason, but the decompiled version needs both of them in for the compiler to optimize it out again. So here we have a loop, and this looks like a pretty standard for loop. We're going through and looking at primitives. We should replace these variables, and we'll get the common idioms in place. So what it looks like to me is that we are looping as long as primitive is not null. That got us a little further back, but that's okay, because I think this will end up being the structure. It may, no, it can't be a do while, because we were checking whether primitive was null at the beginning. And so here we see some of the funny instructions that are being generated by this multiply high. And so the decompiler put this in kind of as an intrinsic. An intrinsic is a instruction that the compiler, it looks like a function call, it looks like a normal type, but the compiler will treat it specially. And so the M2C kind of emits this multiply high intrinsic when that's not really what's happening, and we'll have to figure out what that is. But again, based on like the magic numbers in here, let's see where those. I don't see where those are coming from in the original though. Anytime I see magic numbers like that related to, here they are up here, different operations, it seems like a modulus or a division, and here we have some of that. So it may be related to that. I'm going to keep going and rename variables just so that I can follow this logic a little better. This var S03 is going to be a variation on the primitive. So we can call all those prim, and S0 is as well. But let's get rid of S02 first. We'll call that X offset. I know, magic numbers are great. I was looking at, so yesterday we looked at, not Masamune. Maybe it was Masamune. Yeah, Masamune and Miramasa. And these have such awesome animations, especially Masamune. And so we were going through and decompiling some of the functions that are generating these, and definitely not my strong suit. I did a lot of math, and a lot of math related to graphics, but it's now decades since I've been in that world at all. So when I see these, one, it's interesting that how much of this is programmatically generated effects versus sprites or other sprite work. But just the combination of like artistic talent and programming and math all kind of coming together to do these effects is really cool. That's one of my favorite parts about game design and gaming and game programming, is how all of these disciplines have to come together to get something that is both fun, people want to play, but also looks great, and kind of takes you on a narrative story, anticipates what you as kind of the person filling the role of this character, what your wants and desires are in this game world. There's just so much that goes into game making. So I'm going through now and getting rid of temporary variables that are unnecessary. And as those are removed, a lot of times we'll get closer to a match. Sometimes not. Sometimes we need the external variables. There was another issue yesterday as well where there was some pretty common, just an addition operation. We have some constant and we're going to add it to a variable and assign it to another variable, and that's going to be used in a calculation. And if you use that constant value in line in that assignment, the wrong code was generated. You had to explicitly assign a constant to a variable and then operate on that variable with the further arithmetic operations that were being done. So we can't always get rid of them, but most of the time we can. Looks like all of these might... no, that's not prim. Just making sure that this primitive index isn't being used elsewhere. It looks like not. So another case where we can decrement the timer. This is another idiom that M2C doesn't understand. When decrementing, or when looking at a 16-bit value, for some reason it generates the shift. It treats it as a 32-bit and then generates the shift. So Eldritch mentioned that they're looking at doing enemy stats randomization. I can try to find a relevant area, but this there's similar constructs in weapons as well, where different parameters that are set for that entity, which params is opaque and treated differently for every entity. That affects what logic gets executed, which may or may not change stats as well. Does that make sense? And I don't know if that's what you're seeing, but I could definitely see cases where there isn't a preset value for a particular enemy stat, but that it's set programmatically based on params. I see. and that makes sense as well. So the rando doesn't read the ISO. I've looked at it a little bit. The way I interpret it is the rando knows what address offsets are into the different files on the disk, and then is building a patch based on those offsets without having to ever actually do a diff or anything like that. And the patch is then done client side. Unless, I guess you can upload your ISO too and have the patch applied. I don't know if you were on the stream last week, but I spent some time, I think, on that Wednesday. So this was Thursday of last week. I did spend some time looking at what randomization would look like at compile time. And starting weapons, for example, generated a demo where you could set the weapons at compile time. And pulled out a bunch of definitions there. I do think that, so we have a pretty good, if you're building from source in the Decomp project, one of the things that you get is a map of variables to addresses. For static variables, those entries don't get put in the map because nothing needs to read them. But for some of these stats, for example, there may be using that map to identify the addresses and offsets may be helpful. And I can walk through that. Let me see if I have this open. I'll pull up my starting items. Oh, I didn't want to set the background. Not able to drag and drop. Yeah, so this was my starting item, and Death stole my hot dog, my Frankfurter. Very sad. So the one change that I made when doing that, and I probably won't have time today actually to go through that, but why don't I pull that up? I don't think we're going to finish this in the time that I have remaining anyway. Let's look at my branch. One of the nice things beyond basically being able to track where all of the variables that are being reused are is that logic can be randomized easy. And I know that the randomizer does a ton of logic changes, and honestly I don't know who the masochist is that would have gone through, probably you and others, Eldritch, and tweaked functions to change their behavior and things like that. That's well beyond anything that I can do, or would want to do, actually. How do I compare this? Oh no, wasn't this my branch? Not random. Sometimes I hate GitHub. I just want a diff. So in this proof of concept, basically I made some additional flags and then pulled out all of the starting items. And so the starting items then were bound to macros that could be set at compile time, along with potentially preset modes as well. And so the interesting part about being able to have source is that you can add additional logic too. So by default you don't have a second starting accessory, but if the logic I added says if you do have a starting accessory, you can allow death to steal that as well. The death animation sequence, however, is hard-coded for 6 items, and so when those get pulled out, you're limited. We don't have all of NO3 decompiled yet, so if I was going to change the size of this array, that would change other offsets at the moment, and because we don't have everything decompiled, that could break other things. So I didn't go that far into that change, but it was fun to see. And what was interesting as well is the order that death steals these items is, or that they're animated, is different from the order that they're taken from you in the game engine. Yeah, that's right. All right, let's keep going. So we have some register differences. Those usually shake out as other things are corrected. Line 57. This is always put out of order. And so when we put that back in order, those work out. Here we're loading on line 65. This is the same thing that was seen earlier. These are being loaded as unsigned when they should be, when the variable itself is normally signed. Actually, the second one's unnecessary. Oh, it is necessary. That's odd. On line 70, there is an assignment of 1 that looks like it's happening out of order. And those line up. And then on 83, it looks like something similar. And we'll change this to an increment. This is going to be accessing this field at this particular offset. And so that works. So we still have registers that are wrong. I'm a little surprised that they're so pervasive, which might mean that there is some logic. This may be it. So the decompiler generated this, but logically it's the same as just doing the while. And it looks like we have that a couple other places. So that might be the source of some of this register mismatch. So I was on line 88. I'm going through and looking at the current assembly versus the target assembly, and when I see things such as this on line 89, where this in our code we have it loading this velocity y into a temporary variable, And then comparing this temporary variable, I don't think we need these. The odd large hex values are because these are fixed point numbers, which is something that we don't often see in modern systems. But those will be changed to macros to make them more easy to read. Oh, sorry, I needed temp A2. And to get a better idea of what that is, oh, maybe that's not a fixed. If it is an odd value. I'm going to look at velocity y elsewhere. No, they are fixed. We've not seen a fixed value of that. I guess precision. Oh, I may know why. Let's see. This is being generated correctly. I'll leave it for now, and possibly have to come back to it. So down on line 105. So checking the high bit of a 16-bit value, if it's a signed value, basically is asking whether or not this is a negative value. And for whatever reason, the decompiler did not know that and treated it as a 32-bit value. So we can say, is it less than 0? And that should give us the same thing. Line 108. Here we're setting a temporary variable and then assigning it. Usually those are just set in each condition. Line 112. There are a bunch of casts here that may or may not be necessary. I'm going to remove them and see if that gets things closer, and if it does, great, and if not, we can try to figure out what the original is doing. So that got things closer. Not exact yet. So one of the values is, these are 16-bit values. sometimes this pattern of shifting left logically and then shifting back right is to clear the high bits of a 32-bit value. I'm not sure why it would be necessary here, though. I'll come back to that. I'm not positive why that may be going on yet. Often these are out of order. But maybe not now. Again, this will be a fixed value. So here, this may be a divide equals by 2. Yeah, I don't see anything particularly interesting there. This will be a plus equals. And I'm guessing, oh, this one, the second collider is behaving and generating all the correct instructions. So there may be something earlier that is affecting how the collider above is generated, or the call to check collision, because this one seems fine down here. Otherwise very similar, though. Some factory work, that'll be changed to various factory macros that we have. We see another while loop that is not quite right. So this is a longer function, but not terribly long. I'm primarily going through and looking for anything obvious that, were it to be changed, would affect anything substantially. And I'll come back over here and go backwards. The register allocation is strange. But again, I think it's probably some instruction or line that's just not written correctly, or so this is something that I saw the other day and may clear some things up as well. Let's find where this assembly is. This is 182. So there are other places where this ordering makes a difference, and it does here as well. Typically, the top of the so factories are 16-bit values when they're in weapon functions. The hand ID influences how that 16-bit value is going to be calculated, and a particular 2 bits will be set based on that. And usually the remaining kind of static part of that is based on some high-level something at the top of those. Sorry, it's a 32-bit value. Something in the top 16 bits set one particular way, and then the bottom bits set to some constant value. And they're usually ORed together, but in the weapon functions that we've looked at in the last couple days, they are not. They're not done that way. These might have the same issue. Oh, this one's even stranger. Oh no, it's not strange. So this one is not having to use the current entity to choose what the entity factory is. It's just based on the hand ID. Let's look at line 112 where we have a bunch of missing. So first we're loading an unsigned, or we're loading a signed value where an unsigned was being loaded. So that fixes that line. This is being loaded as a signed 16, but then no, it's being loaded as a, sorry, that's all correct. This gives us our shift left. Yeah, so these cancel each other out. I'm not sure. And if I do it after the... Oh, it is happening after the subtraction. They should still cancel each other out. But they don't. That is odd, and I'm not sure why. So when we shift those over by 16 bits and then shift them back, the subtraction may have overflowed the 16-bit boundary into one of the additional bits in the 32 bits of the and so this is just clearing that upper 16 bits and allowing the overflow to happen. So that makes sense. So there's still more work to be done here. We're at 90%. This should be completable in maybe another 30 or 45 minutes. I'm out of time today, though. So next week, I think I'm going to start streaming a little later, probably starting at 11 a.m. I'm in Mountain Standard Time, but that's PST for anybody not in our vortex of lack of daylight saving. So I'll be back at 11 a.m. on Monday and go Monday through Thursday again. And we'll see how far weapons get over the weekend. we should be in the low teens, hopefully, if the pace continues. And maybe sometime the week after that, weapon will be done, and then we can start or finish importing data there and have a relocatable weapon object. That would be awesome. If you want to know more about the Castlevania Symphony of the Night decompilation project, you can go to SOTN.z.dev. You'll see progress for the objects that were in the process of decompiling. There's links to the GitHub repo where you can learn more about contributing, learn more about how to decompile parts of Symphony of the Night and the tooling that has been built around it. There's also a link to the Discord where we're chatting about various things related to decompilation. Some talk about ROM hacking and other modifications that could be made to the game, as well as making the code as portable as possible so that we can reuse as much of the code as we can on the PlayStation, PSP, and other versions of the game. Other than that, I'll be back on Monday. Thanks for tuning in. And if you were here earlier, you saw the fastest Symphony of the Night decompilation of a weapon function in history. That's right, we made history here today in the Made Up of Wires stream. Thanks, everybody.